Imagine, if you will, a void of nothingness, a blank canvas waiting to be filled. What could possibly emerge from this abyss of emptiness? It's a riddle that has perplexed the greatest minds for centuries. The enigma of existence, the unfathomable vastness of the universe, and the complex concept of time itself all pose questions that are as intriguing as they are elusive. These mysteries, though daunting, invite us to explore, to learn, to understand. From this nothingness, a universe was born, a universe teeming with galaxies, stars, and planets. The universe didn't always exist as we know it. Its birth as we understand it today is attributed to a cosmic event known as the Big Bang. Around 13.8 billion years ago, everything that now forms our universe was condensed into a singularity. A point infinitesimally tiny and incredibly dense that contained all the matter and energy that would come to form everything we know and see today. This singularity, smaller than an atom, suddenly and violently exploded. This wasn't an explosion in the traditional sense, like a bomb detonating in space. Instead, it was an explosion of space itself, an expansion, a cosmic stretch. In fractions of a second, the universe grew from something almost infinitesimally small to an entity of vast size. As the universe expanded, it also cooled. From a state of unimaginable heat and density, it began to cool down and become less dense. This cooling process allowed the fundamental forces of nature to separate and work independently. Gravity, electromagnetism, and the strong and weak nuclear forces began to carve the universe as we know it. After the first few minutes, things cooled down enough for the first atoms to form. These were primarily hydrogen and helium, the simplest and lightest elements. These atoms were scattered across the universe, forming a cosmic fog. Over millions of years, gravity began to pull these atoms together, forming the first stars and galaxies. These celestial bodies lit up the universe, clearing the cosmic fog. It was like the universe had turned on its first lights. Over billions of years, these stars and galaxies evolved, leading to the universe we see today. A universe filled with billions of galaxies, each containing billions of stars, possibly with planets of their own, each with a unique story to tell. And so, from a singularity smaller than an atom, the universe as we know it began to take shape. This is the dawn of the universe, a story of creation, not from an external force, but from within. A story of how the cosmos came to be, from a point smaller than an atom to the vast, ever-expanding universe we are part of today. The universe evolved, unfurling like a cosmic tapestry over billions of years. This evolution, a grand spectacle of cosmic ballet, gave birth to the stars, galaxies, and planets we see today. Imagine a cosmic soup, a primordial mixture of matter, energy, and time. As this cosmic soup cooled, tiny fluctuations of matter began to clump together, creating the first stars. These stars, acting as cosmic forges, fused hydrogen atoms together to create helium. This process, known as nuclear fusion, released incredible amounts of energy, lighting up the universe for the first time. As stars aged, they began to fuse heavier and heavier elements, creating everything from carbon to iron. But some elements, those heavier than iron, required a more dramatic birth. These elements, like gold and uranium, were born in the spectacular deaths of stars in events called supernovas. Supernovas, violent and beautiful, scattered these elements throughout the universe. Now, let's shift our gaze from stars to galaxies. Galaxies are like cosmic cities, home to billions, even trillions of stars. These galaxies formed when gravity pulled together huge clouds of gas and dust, creating swirling spirals, elliptical hordes, or irregular clusters of stars. Our own galaxy, the Milky Way, is just one of countless galaxies in the universe. But what about the planets, like our dear Earth? Planets formed around young stars in regions known as protoplanetary disks. Tiny particles of dust in these disks stuck together, forming larger and larger clumps. Over time, these clumps grew into the planets we see today. And let's not forget the cosmic background radiation, the afterglow of the universe's fiery past. This radiation, detectable today, is a relic of the universe shortly after the Big Bang. It's a cosmic echo, reminding us of our universe's explosive beginning. The universe, once a fiery, formless expanse, had transformed into a cosmic wonderland. From the births of stars to the formation of galaxies and planets, the evolution of the universe is a story of cosmic forces, elemental creation, and time beyond human comprehension. The universe's story is far from over. As we gaze into the vast expanse of the cosmos, we find ourselves contemplating what the future might hold. Scientists have been pondering this very question, and they've come up with a few intriguing theories. Let's start with the Big Freeze theory. This is based on the idea that the universe's expansion is accelerating. If this continues indefinitely, the cosmos will become increasingly sparse. Stars will run out of fuel and cease to shine, leaving only black holes. Over unimaginable timescales, even these would evaporate, leaving a cold, dark universe. Next, we have the Big Rip theory. This is based on a different interpretation of the universe's expansion. If the rate of expansion is not just increasing but accelerating rapidly, then the fabric of space-time could be torn apart. Everything, from galaxies and stars to atoms and subatomic particles, would be ripped to shreds. Then there's the Big Crunch theory. This suggests that the expansion of the universe might one day reverse. If this happens, all matter and energy in the universe would begin to collapse in on itself. The universe would become denser and hotter until everything merges into a singularity, a point of infinite density. These theories may seem dramatically different, but they all hinge on the delicate balance between matter and dark energy in our universe. Dark energy is believed to be driving the universe's expansion, while matter tries to keep everything together. The future of the cosmos depends on which force wins out in this cosmic tug-of-war. But these are just theories, models of what might happen based on our current understanding of the cosmos. The universe has a knack for surprising us, for revealing complexities that we couldn't have imagined. As our understanding evolves, so too will our predictions for the universe's future. Whatever the future holds, the universe continues its cosmic dance, ever-changing, ever-evolving. In this vast cosmos, where do we fit in? This question is as old as humanity itself, and the answer has evolved as we have. Once, we believed that Earth was the center of the universe, with everything revolving around us. But as our understanding deepened, we realized that we were not the center, but rather a tiny speck in a much larger cosmic web. Let's explore the concept of the observable universe. This is the portion of the universe that we can see from Earth or its space-based telescopes and detectors, given the age of the universe and the speed of light. It's a sphere with a radius of roughly 93 billion light-years, containing about 2 trillion galaxies, each filled with billions of stars. We're located in the Milky Way, one of these many galaxies. Yet even with such gigantic numbers, it's important to remember that this is just the observable universe. There may be more, much more, beyond what we can currently see or comprehend. Our universe could be an infinitesimal part of a larger multiverse, or it could be one of countless bubbles in an eternal cosmic foam. Our understanding of the universe has come a long way since the days of Earth-centric models. Now we know that we're part of a galaxy that is itself only a small part of an enormous cosmic web of galaxies, linked by invisible threads of dark matter. This web stretches across the observable universe, a testament to the grand scale of the cosmos. As we delve deeper into the mysteries of the universe, we learn more about our place within it. We may be small, occupying a minute corner of the cosmic web, but our quest for knowledge and understanding is vast. We're the universe contemplating itself, seeking answers to its own existence. In the grand scheme of the universe, we may be small, but our quest for understanding makes us significant. So let's keep looking up, keep searching, and keep asking questions. Because our place in the universe is not just about where we are, but also about where we're going. The universe, a frontier uncharted and unexplored, it's a vast expanse of cosmic majesty that teems with mysteries and wonders. It beckons us to venture beyond our pale blue dot, urging us to step into the unknown and to seek what lies beyond the stars. Space exploration isn't just about strapping rockets to our backs and hurtling through the cosmos. It's a quest for knowledge, a thirst for understanding. It's about unraveling the threads of the universe, decoding its cosmic script, and peering into the very heart of existence itself. Every discovery we make, every star we catalog, every planet we unveil, it paints a richer, more intricate picture of the cosmos. Yet, with each revelation, it seems that more questions arise. We find ourselves standing on the precipice of new mysteries, gazing into the abyss of the unknown. It's these questions, these enigmas, that fuel our pursuit of knowledge. We're explorers by nature, eternally curious, forever yearning to understand our place in the cosmos. It's a journey that's taken us from the primitive cave dwellings of our ancestors to the towering skyscrapers of our modern world, and now towards the stars. As we gaze out into the cosmos, we realize that the journey of understanding our universe has only just begun. The universe, our final frontier, continues to beckon, whispering of secrets yet to be discovered and tales yet to be told.